Hello students, my name is Charles Makori and it's nice to have you back. I'm a teacher of physics chemistry, but here I'm having a physics question which mostly disturbs the student involving finding the density of a solid using the density bottle, and here is a breakthrough. I hope you will understand. Yeah, let's go through this question. So the question goes, in an experiment to determine the density of aluminium using a density bottle, the following measurements were recorded. Mass of empty density bottle, 10 grams. Volume of empty density bottle, 50 centimeter cube. Mass of density bottle with some aluminium, 60 grams. Mass of density bottle plus aluminium plus water, 90 grams. Use the above data to determine the mass of aluminium, mass of water that fill the space above the aluminium, volume of water that fill the space above the aluminium, bracket density of water 1 gram per centimeter cubic, volume of aluminium, and finally you find the density of aluminium. So this particular problem is not quite difficult as most students take it. You only need to understand, I think the only challenge that most students have is finding the volume of like that solid. So I want you to give you the solution of the finding this volume. You usually use the volume of the known so that you can gain the volume of the unknown, and mostly I will use the volume of the liquid, which mostly it happens to be water. So if the density of water you are given or not given is obvious 1 gram per centimeter cubic, and the mass of water obvious, we have to find it. So getting its volume, it's easy. And in this particular problem, we have been given the volume of the density bottle. And if we get the volume of water, then definitely we can get the volume of the aluminium. And if given its mass, then we can find its density as easy as that. So let's break through each question. Roman 1, mass of aluminium. So to get the mass of aluminium, we've been given the mass of the empty density bottle to be 10 grams, and the mass of this density bottle with some aluminium, some. Underline the word some. So for example, this is that density bottle. Yeah. The mass of this empty density bottle, it is 10 grams, but with some aluminium, let's say this aluminium, so its mass increases to 60 grams. So finding the mass of this aluminium, we just take the total mass of this empty density bottle with the aluminium, some aluminium in it, minus the mass of this empty density bottle. You get it to be 60, which is the total mass of aluminium in the density bottle. You minus 10 grams, which is the mass of the empty density bottle. Your answer gets to be 50 grams. And there you have your mark. Roman B says, mass of water that filled the space above the aluminium. Meaning this water was added. There is a stopper here. So the water was added, which filled the space surrounding here until it was full, and the space that was left there. So mass of empty density bottle plus aluminium plus water, the total mass is found to be 90. So getting the mass that fills this space, we just take the total mass minus the mass of empty density bottle and aluminium. We remain with the mass of water, which in this case is 90, which is the total mass, minus the mass of empty density bottle and aluminium, which is 60 grams. Your answer gets to be 30 grams. You have also your own mark. So Roman C says, volume of water that fills the space above the aluminium. We've got the mass of this water. Now we have to find the volume of this water given the density. So we start with the density we have been given to be 1 gram per centimeter cubic. And the mass of this water, we get it to be 30 grams. So we have been asked the volume is what? Just use the formula, this one, dmv. So getting the volume is mass over density. So this volume is the mass, which is 30 grams over the density, which is 1 gram per centimeter cubic. These grams and grams cancel, and our final answer becomes 30 centimeter cubic. Are we together, student? Right? I'm sorry because the space around here is too small and my work is very dirty, but I'm sorry for that. So Roman D reads the volume of aluminium now. You know, aluminium, the solids have a definite shape, but getting the volume, getting its volume here, we have to use the volume of the known one, which is the volume of water we've gotten here, and the volume of the density bottle we've been given up here to be 50 centimeter cubic. If we take this volume minus the volume of water inside, we will be left with the volume of aluminium as easy as that. So you take the 50, which is the volume of the density bottle, you minus 30 centimeter cubic, which is the volume of this water. We remain with the volume occupied by the aluminium, which is 20 centimeter cubic, right? And finally, density of aluminium. So from the formula here, density is mass of aluminium. So mass of aluminium, we got it up here to be 50 grams. So mass is 50 grams, right? And the volume of aluminium is, we got it to be 20 centimeter cubic. Just apply the formula to get the density. Density is mass over volume, right? So its mass is found to be 50 grams over the volume 20 centimeter cubic. So you get the density to be how much? Use the calculator to get the answer to be 2.5 grams per centimeter cubic. As easy as that. Thank you for watching. Please subscribe to my YouTube channel for more.